So there are 6 resistors. First, you find potential at X, then you find potential at Y, and then subtract the two potentials. How we find potential at X? It's a 2-volt total. In parallel, voltage is the same. So how the voltage will be divided on the 3 resistors in line? In parallel, voltage is the same. So it will get a potential of 2/3 volt. It will also get a potential of 2.3 volt. It will also get a potential of 2.3 volt. Now, these are the 3 voltages. Can you tell me what will be the potential at point X? Taha, you can also participate in the question. We are doing some trial questions here. This is question number 24. We have started. So if you take potential at this point, I want to find the potential at X now. This is the point X. Let's say let's say I read from here. This is my reference line. No, but if I read from the reference line, it will be 2/3 plus 2/3. It doesn't matter. You have to take a reference line, Taha. 2/3 is not wrong. 2/3 means you were taking that reference line at the top. You can take anywhere, but you should take for both X and Y the same reference line. Now find the potential at the lower point here. Same potential 2/3 volt. Like this. So now find the potential between X and Vx minus Vy. Subtract the two potentials. Might check the answer. This is a solve book, so you can check the answer. We are getting 2/3 volt after the working. So now next question. Select Please put now. I have taken one question from Mahin. She is putting her second question. Meanwhile, you look for the question and please put it here. Acha, Mahin, you says question number 40. Yes, Taha, you can also put meanwhile we solve 40. Okay, Taha has some question also. Acha, this question, Taha, let's solve it together. It will be a practice. A hinge door is held close to the horizontal position by a cable. Three forces act on the door: the weight of the door, the tension T in the cable, and the force H on the hinge. Which list gives the three forces in increasing order of magnitude? Simply extend the forces, let them meet at a point because the system is in equilibrium. Equilibrium forces, when they are extended, they meet at a common point. So let me extend it. I have extended the forces. So I have extended the forces. You can see which is the longest force, W, H, and T. So W is the shortest force. W is the shortest force, and we can find the order. Taha, your feedback. You can see the length. Now the length is in front of you, no? Hmm. So this is the physical drawing. So you can see the visible, na? It's visible. T is the longest force because it has the highest length. Yes, Taha, your question, please. Now it's your turn. You can ask a question. February, March 2022, question 3. Acha. February, March 2022, question 3. Okay. We have to tackle this question. Is this the question? Look at the question, please. Okay, let's do this question together. Mahi, this is a question, and Taha had this question. This looks to be a potential divider case. Hmm. Now, the circuit shown the cells have negligible internal resistance and the reading on the galvanometer is zero. Reading on the galvanometer zero means what? Actually, zero is possible if the potential here and the potential here, let me call V1, V2. It means V1 should be equal to V2. Voltage is always divided in the ratio of the resistors. It's a potential divider question. So 9 upon, what's the value of the resistor R? It is possible only when V1 is equal to V2. First, because the circuit is not completely parallel, I put a question mark here because there is no, I put a question mark here because there is no wire here. So let us try to find the voltage. There are two power sources in the circuit. One is 9 volt and one is 4 volt. I don't know the answer, but I need the method because I was thinking I can apply 4 volt and divide 4 volt in 9 is to 3. If I did, because voltage in a series circuit, voltage. So I have given a plan. Now let's try this plan. We need to find, actually, there are two power sources. They both are connected from their negative terminals. So we find the potential at V1, you find the potential at V2, and then you have to make a ratio because the voltages are in the, because he says V1 is equal to V2. First we find V1, then we make a value for V1, then we make a ratio R upon 6. When cells are connected with like polarity minus to minus, you can subtract them. The resultant voltage will be 5 volt. Okay, uh, let me start it. I think you people are not giving the feedback. So the ratio is 2 is to 1. Remember, to get the same voltage, you need a same ratio of resistors. What's the concept to remember? Ratio of resistors. Ratio of resistors is the ratio of voltages. So it is 9 is to 3. So the ratio is 2 is to 1. I repeat, there is no wire here. We also need the same ratio, 2 is to 1, on this side of the resistor R. So 2 is to 1. C looks to be the right answer, but I need a reason for it. Ratio should be 2 is to 1. Yes, Mahin, your question now. Same worksheet, question number 41. Taha, you also look at this question with us and we together solve it. In an interference experiment, two slits are illuminated with white light. What is seen on the screen? Central fringe should always be bright white. Central maxima is always bright white. Central fringe is always white. He's sending us white light. So white light consists of 7 colors. No, actually, it should be colored, na, Taha. It should be colored because white light, when it passes through a prism or any refraction medium, it should break into 7 color. Now, Taha, your choice. Taha, you put a question now. Calibration curve, acha. Taha has a question, May, June 2022, paper 1-1. Okay. This calibration curves are not important now. There was a topic, but now it's only one that our O-level concept that calibration is making a numerical scale for a measuring device. That's all. Nothing more than that. Let's address now. Let's address Taha question now. So June 2022, paper 1-1 and question number 6. Now look at this question. A ball is thrown horizontally with a speed of 10 above horizontal ground. The ball hits the ground after a time of 3 seconds. It looks like a projectile question. Now this is the motion. Just before, when it is thrown horizontally, it means there is no vertical component, but later vertical component will come up because it's a case of projectile. So this is my horizontal velocity. And later when it hits here, look, it hits here. I have made the data and I think it's a case of projectile motion. So I have made data according to projectile. Now start it. I have made the data and it's a projectile motion question. We need to find the speed of the ball. Speed of the ball before it hits the ground. So we need to find the velocity. U is equal to 0. A is equal to positive G. Time is equal to 3. I will first try to find the V, which is actually equal to Vy. So you people can help me to find the V, which is actually Vy. I'm talking about the final vertical component. What formula should I use? But we don't have distance now. Try this and get the answer for me. This is my Vy. What is 9.8 into 3? Hmm. 29. Acha, 29.4. Oh. Acha, I get 29. And now I have to find the final velocity, which is the resultant velocity actually. This is the formula. Look at this. Okay. He's asking the ball. He's not asking for any word. Look, when he says horizontal, he said horizontal. Actually, he uses the word the ball just before hit the ground. So when something is hitting the ground, it will be obviously the resultant velocity. He's not asking for horizontal or vertical. In a projectile motion, the speed at which the ball hits something is always the resultant velocity. So find it. Okay, Taha, you can say namaz. I'm just coming back in 2 minutes, but mine, can you solve it? So get the answer. I'm just coming in a minute. Please get the answer and compare the answer. Did you get the answer? C. What calculation answer is coming? Yeah, 3.0 or 31 point. 31.05. Right, right. Aha is not back yet. You can put your next question, please, Mahin. Hmm. Question 47. The diagram shows a sign of weight 20 newtons suspended from a pole attached to a wall. The pole is kept in equilibrium by a wire attached at point X of the pole. The force exerted by the pole at point X is F. Now we have number of forces. He says there is a tension in the wire 40 Newton. Tension always move away from the point of action. Tension, if you are standing at position X, tension always work opposite, going away from the point. Now draw these forces and now make a triangle. Apply triangle rule. Join the forces head to tail to make a close triangle. But it's not forming a close triangle. What is force? Oh, either we have to show the force F in opposite direction because otherwise it won't make a close triangle. In this direction, head to tail won't make a triangle. We have to rethink. We have to rethink the direction of the force. I'm showing the force now in this direction. So now try to make a right angle triangle. Oh, sorry. Now try to make a closed triangle. Remember, all arrows should be going in a cycle. It should be a zero resultant force. A is wrong because A is showing that F is the resultant. B is possible. C is wrong because in case of C, 40 Newton is the resultant. Equilibrium means no resultant. Equilibrium means no resultant. D is wrong because D is showing 20 Newton is the resultant. So we have only a limited choice available. Resultant force should be zero. All the vectors should be joined head to tail and there should not be any resultant. The answer should be B. So we stop here and we will try to put another class, inshallah. And if you have queries, you can mark and we will do more classes in this way. We are stopping here, inshallah, in the next class. Allah Hafiz.